When I was 8 years old, my best friend dared me to go down a slide at a water park called the Black Hole. So naturally, as any 8-year-old would do, I jumped down, slid through, and shot out the slide so fast that I almost drowned. Looking back on it now, I regret taking the dare, but once in a while, we all do something we regret. Whether it be taking a risk, treating someone poorly, or making a wrong decision, we're only human, and we make mistakes. But what if I told you that according to many physicists, we have, at some point in space and time, led a perfect life for ourselves? According to the theory of the multiverse and multiple dimensions, there are an infinite number of yous living an infinite number of lives in an infinite number of ways. This means that, in at least one of them, you must be living exactly the way you've always wanted. But this theory's uses extend far beyond mere hypotheticals. Multiverse theory is the answer as to how complex life managed to exist and thrive against all odds, a question many of us have pondered from time to time. If any of the starting conditions of our universe were off by even the tiniest bit, we'd cease to exist. So our universe would have to be extremely fine-tuned for us to occur, right? No. At least not according to the multiverse theory. So today, let's jump down this theory's history, slide through what a multiverse is, and shoot out the other side, with its possible applications and implications. So first, let's jump down the multiverse's past. According to The Beginning of Infinity, a book published in 2011 by David Deutsch, a Nobel Prize-winning physicist named Erwin Schrödinger was the first to propose the idea of the multiverse in a lecture he gave in 1952. He reportedly said that what he was about to say might seem like lunacy, but his Nobel Prize-winning equations seem to describe multiple histories that were not alternatives, but all really happening simultaneously. This sent everyone a buzz, so people started looking for evidence to turn it into a theory. So they looked, and looked, and looked. It took almost 50 years before the first shred of evidence came around, but it was intriguing. See, physicists at the time realized something that we almost all know to be true today, which is that the universe originated from a big bang. But because of gravity, this bang should be slowing down. Instead, it's speeding up, and whatever may be causing this, we dubbed dark energy. This energy's density, also known as the cosmological constant, is way smaller than the theory says it should be. In fact, Paul J. Steinhardt stated in a research article in Science magazine that the observed value was over 120 times smaller than what they'd expected. This seems bizarrely specific, so naturally, physicists were dumbfounded by this discrepancy and craved an answer. Enter multiverse theory. The idea that there were an infinite number of universes, all with their own cosmological constants, solved the problem as to why ours was so strange. It's because in other universes, it is what we expected it to be. But in our universe, this constant just so happens to be perfect for forming planets and galaxies. Over the next few years, this started to occur everywhere in the physics realm. Multiple mysteries seemed to be solved by this theory, and more people started to accept it. So now that we've taken a look at how this theory came to be, let's slide through what a multiverse is in more detail. So far, all we've been able to say is, hey, my idea has an internal logical consistency, and it works well with what we know in real life. Essentially, physicists have mainly fleshed out the theory through assuming that it's true first, and then finding out more about it from there. Obviously, we have evidence to suggest that it may be real, but our evidence mainly consists of gaps in other theories. So all we need right now is one piece of hard evidence to connect it to the real world, and we're golden. But until then, we're mostly postulating. That, however, is how we know what we know. But let's look at what the multiverse is in more detail. Some physicists like to think of it as an ocean. According to an article written by Mark Prigg in the Daily Mail in 2014, our universe is one bubble in a frothy sea of bubble universes. To understand what he's saying, we must first think about the size of the Earth. This alone is almost unfathomable to most of us, but light can zip around the Earth 7 times within a snap. Now think about how far light could travel in a year. Not a second, not an hour, a year. By now we're way beyond what anyone on this Earth could even imagine. But let's go further. What about 90 billion years? Well, that's the width of our universe, but we're not done. Think about something that incomprehensibly large being the size of a water droplet. This theory proposes that there are trillions upon an infinite number of these droplets, which make up an ocean of gigantic proportions. Think about that. Finally, now that we've taken a look at what a multiverse is and how the theory came to be, let's shoot out the other side, with its possible applications and implications. If multiverse theory is correct, it solves numerous problems that physicists face today. For example, Robert Kuhn wrote on Space.com in 2015 that multiverse theory explains why our early universe was strangely uniform. Another article written by Marie Jones in New Dawn magazine in 2015 states that multiverse theory solves many issues regarding the mathematics of time travel. So this theory could solve many of life's deep mysteries, and not only allow us to move on to more complex ones, but also allow us to focus our faculties on ones we've been working on for much longer, such as unifying the 4 fundamental forces of nature. With these mysteries solved, we could come one step closer to solving things such as interstellar travel, which is extremely important to the survival of our species, or what's at the center of black holes, which is essential for our understanding of space and time as we know it. All we need right now is someone to connect a piece of hard evidence from the multiverse to the real world, and this case will be cracked wide open. So today, we looked at the theory of the multiverse and multiple dimensions, from its origins to its possible applications and implications. We delved into this theory's history, talked about what it is, and predicted what this could mean for our future. But the multiverse is so much more interesting than what I can fit into an 8-minute speech, because there's so much more to discover, and it's important that we do. Now I'm sorry, but this speech must come to an end. I wish it were longer, but think of it this way. In another universe, it is.